Welcome pre-cal students to class today on this Thursday the 24th. Hope you guys are doing well. Hope you're ready to learn some math today. There will be a test this coming Monday, so make sure that you are ready for that. We will have a review sheet on Friday. And remember, no video on Friday, just the review sheet, and I will email that to you later, okay? If you cannot make the test on Monday, please let me know no later than Sunday. Please stay on top of your integrity sheets. When you come in Monday, you will not be allowed to do any more of those. So make sure you're finished with those. It gives you 5 bonus points on your next quiz, and also it gives you good homework grades. So please stay on top of those. Okay, let's quickly review what we have covered so far this week. Here we go. We talked about direct variation. You should be able to solve problems using direct variation. Using this model right here, y equals kx. You should also be able to solve problems that are inverse variation problems using this model right here. Okay, and then also you should be able to do combined variation. The main word I think of is joint, J-O-I-N-T, joint variation, and that is the same thing as direct, only it involves more than one variable with your constant k, something like this, y equals k x z, or something like that. So make sure you're familiar with those types of problems. Then yesterday we talked about inverse functions, and I showed you what inverse functions are, or inverse equations. They're equations that have complete opposite or switched domain and ranges. Okay, so you should be familiar with that. I'm not going to reteach it, but you should understand this. And then also you should understand how to find an inverse function. I gave you 2 steps here. Where the x's are, you put y's. Where the y's are, you put x's. And then if possible, you solve the equation for y. So we talked about all of that yesterday. Also, we talked about the horizontal line test. If you have a graph, maybe an elliptical graph like that, if there is one place that you can draw a horizontal line, just one place is all that you need, in which the horizontal line intersects the graph in more than one place, then you do not have an inverse of that graph. Okay, and it's called the horizontal line test, and we talked about that yesterday. And then also we took something like this and we learned how to reverse the ordered pairs. If I wanted you to write the inverse of this red graph right here, then you take all the given points and you reverse them. So -6, -3 would be -3, -6, which would be down here. And then you reverse all the points, excuse me, and then sketch the inverse graph. So you should be familiar with all of those types of problems. If you're not, review, go back and watch the videos, make sure you're really caught up on your math. Okay, guys? All right, let's continue on. Now, we are going to finish lesson 4.1 today, and we're also going to finish lesson 4.2. So we do have a lot of work to do, and we will be spending time in both of these lessons. There is a method in which you can take 2 equations and prove, or for that matter, disprove that they are inverses. So if you're given 2 equations, there is a way to prove or disprove whether or not they are inverses, and you use the method called composition. Now you might not remember a lot about composition, but we have taken the composition of functions this year. And this is the first thing we're going to look at today, how to prove or disprove that 2 equations or 2 functions are inverses of each other. So your heading today will be proving inverses by composition, or at least one of your headings will be proving inverses by competition. And the date today is 4/24/14. And let's go ahead and get started. When you are given 2 equations, find the composition both ways. And I'll explain what that means in just a second. If you get out x for both, emphasis on both, for both compositions, then you know for sure the 2 equations are inverses of each other. Now, this might sound kind of understandable, but I'm sure it doesn't make total sense to you. So let me just go ahead and give you an example here, okay? Let's take a look at a couple of examples, and I think this statement right here that I'm circling will make sense once we do a couple of examples, all right? I want you to prove that these functions are inverses. Now, I'm well aware of the fact that you could take this function right here, and of course we look at f of x like it's y. So where the y is, you could put an x, and where the x is, you could put a y. And then you could find the inverse of this function, and if you get this out, then you know they're inverses of each other. And I'm well aware you can do that, that's fine. But I want you to learn something else. This is a deeper understanding of what composition of functions is, okay? And so I want you to prove or disprove, in this case I want you to prove that these two functions are truly inverses by using composition. So here's what we're going to do. The first thing we're going to do is we're going to do f of g of x. Remember up here I said you have to find the composition going both ways? So that's one way. Now the other way is going to be g of f of x. Okay? And what should we get out when we're all done with this, and we're all done with this over here? We should get what? We should get an x, and we should get an x. Because that's what it says up here. If you get out x for both compositions, then the two equations are inverses of each other. Okay? So let's see what happens. So let's go ahead and find f of x first. F of g of x. And here we go. So we start with the outside letter, which is f, and so we take our f function and we write it, but everywhere there's an x, we put a pretty big parenthesis. So 5, then x, put a pretty big parentheses, and then plus 8. So there, I have written, I have written the f function, and everywhere there was an x, I put a parenthesis. Now the next letter, working your way inside, we started off with f. The next letter is g. So we're going to pick up our g function right here, and we're going to substitute it right into this parentheses here. Okay, that should ring a bell. So right here I'm going to put x minus 8 over 5. And now let's go ahead and simplify this. Notice first of all you have a 5 outside of a parentheses, and if you want to you can put that 5 over 1. So 5 over 1 times x minus 8 over 5. Well, your 5's are going to cancel, and of course 1 times 1 gives you a denominator of 1, so I'm not going to worry about that. 1 times x minus 8 is just x minus 8, and then bring down your positive 8. And now if we combine like terms, this term here and this term here, they're both like terms, and so a negative 8 and a positive 8 would cancel out, leaving you with just x. Now let's try that over here. Let's complete the composition of g of f of x. Now notice my outside letter is g. So I go to my g function and I write down my g function. The only thing is, everywhere you see an x, you leave a pretty big parenthesis so you can substitute something in later. So here's an x right here. So I'm going to put a pretty big parenthesis and then negative 8 and then all over 5. Okay? Now, notice as I work my way into the parentheses, next is the letter f. So I'm going to pick up my f function, 5x plus 8, and I'm going to put that into the parentheses right there. Okay? So here we go. I'm going to put 5x plus 8. Now, I think it would be wise to first simplify our numerator. We have 5x plus 8 minus 8. So another way to write that is 5x, positive 8, negative 8, all over 5. And then obviously your positive 8 and your negative 8, they're going to totally cancel out. I mean, that makes sense. A positive 8 and a negative 8 are going to cancel out. So you're left with 5x over 5. And then you should know how to simplify that. You have one term over one term, so your 5's cancel, leaving you with just x. So when you took the composition fg of x, you got out x. When you took the composition g of f of x, you got out x. So you know for sure that these two given equations are inverses of each other. And you proved that by doing composition both ways. Okay, now you can pause the video and try this one on your own, or you can watch me. That's totally up to you, okay? But let's go ahead and take a look at this problem. I want you to prove that these two functions are inverses of each other. So here we go. This is my f function. This is my f inverse function. So I'm going to take f of f inverse of x. So I start with my f function, which is right here, and everywhere there's an x, I'm going to put a pretty big parentheses. So parentheses plus 6 all over 3 parentheses minus 4. Okay? And now, everywhere there's a parentheses, I'm going to put my f inverse function, which is 4x plus 6 all over 3x minus 1. And then down here I will also put 4x plus 6 all over 3x minus 1. Now students, I'm going to go pretty fast here. We should know by now that if I want to simplify the numerator, I would put 6 over 1 and I would get a common denominator. And a common denominator for 3x minus 1 and 1 is 3x minus 1. So I would now have this. I would have 4x plus 6 all over 3x minus 1 plus 6 3x minus 1 all over 3x minus 1. There we go. And now I can put those two together. And then we should also know down here real quick, if I put the 3 over 1, I have 3 times this parentheses. So I multiply 3 times the top. So I would really have 12x plus 18 all over 3x minus 1. Okay? And then of course minus 4, so I'm going to put minus 4, and then we would have, let's see, 3x minus 1. Yes, 3x minus 1 all over 3x minus 1. Okay, and now let's go ahead and combine our top here. We would have, and again, I'm going to skip some steps and go fast. You guys have had this kind of math all year, so you should be fine with that. 18x minus 6. And so when you combine those, you should get 22x over 3x minus 1, because your positive 6 and your negative 6 would cancel. And then over here, we would have what? 12x minus 4. Now be careful, it's 12x minus 4, but you're subtracting. So 12x minus 12x, those would cancel out. 18 minus a negative 4 is 22, so you would have 22 over 3x minus 1. So basically what you have is a fraction divided by a fraction, so I'm going to take 22x over 3x minus 1 divided by this bottom fraction. Guys, let's go ahead and flip it. Let's go ahead and flip it and multiply, so it'll be 3x minus 1 over 22. Well, 3x minus 1 cancels with 3x minus 1. 22 cancels with 22. You're left with x times 1 over 1, which is x, okay? I really am trying to save you a bunch of notes. I was going to say let's not go the other direction, but we need to, so I'll go really fast on this one. We're now going to do f inverse of f of x. So we take our f inverse function, and everywhere there's an x, I'm going to put a parentheses. So 4x plus 6, and I'm going to substitute my f function. And then 3 parentheses, and then x plus 6 over 3x minus 4, and of course minus 1. Now, if you put 4 over 1 and multiply it through, your numerator would now become 4x plus 24. Same thing here, put the 3 over 1 and multiply it through the parentheses, and you would have 3x plus 18. 3x plus 18. Now, let's go ahead and take this 6 right here, and let's put 3x minus 4 with it over 3x minus 4. We're just getting a common denominator. We've done this many times this year. And now this 1 right here, I'm going to slide it up just a little bit, and we're going to do the same thing with the 1 here. We're going to say 1 times 3x minus 4 over 3x minus 4. And now I have a common denominator. So let's see, if I take this 6 and multiply it through, I would have 18x minus 24. And now let's go ahead and combine our numerators. A positive 24 plus a negative 24 is 0. 4x plus 18x would give me 22x. And then down here, we take the 1 and multiply it through. It's 3x minus 4. So the 1 there is really not going to change anything. 1 times 3x is 3x. 1 times negative 4 is negative 4. So we have 3x minus 3x, so those are going to cancel out. And then we have 18 minus a negative 4. That's a positive 22. And by the way, I made a mistake right here, and I apologize to you. This 22x should still be over 3x minus 4. Sorry about that. And then also you'd have 22 over 3x minus 4 down here. Now I'm going to stop. Caleb, Matthew, both of you guys do well. You know how you're taking a top fraction divided by a bottom fraction. You know how to take the bottom fraction, flip it, and then multiply, and you see you will get out an x, okay? So when we took the composition both directions, we got out an x. So you are learning a way to prove when equations are inverses of each other by using composition. All right, now let's continue on. Let's move on, and that's the last topic in lesson 4.1. Now I want to totally switch gears. Lesson 4.1 was all about inverses. We're done with that, and now we're going to start getting into logarithmic and exponential expressions. Now today we're looking at exponential functions, okay? So if you would write that heading down, please. Graphing exponential functions, lesson 4.2, of course, it's still 424. Here is an example of an exponential function. Now please look at it carefully. Notice in the exponent you have to have an unknown. Usually it's going to be x. Sometimes it won't be, but you have to have an unknown in your exponent. Notice this is your constant term. It's all by itself. Negative 3. There's no x with it. There's no y with it. There's no t. There's no a. There's no variables with it. It's a constant term all by itself. Please do not think that this 2 is a constant term. This 2 is a multiplier, and it's being multiplied times the 1/3. Now the 1/3 here is what we call the what? You should know the 1/3 is called a base, because if I had 2 to the 3rd power, which one of those is the exponent? 3. Which one of those is the base? 2. 2 is the base of 3. Or you could say 3 is the exponent of the 2. Well, it's the same thing over here. X plus 5 is the exponent of what base? 1/3. Now notice something about your base. When it comes to exponential functions, there's 2 things you need to know about your base. Your base must be greater than 1, okay? So it cannot be, I'm sorry, this is incorrect, and that's totally wrong, and I'm sorry I typed that wrong. Your base must be greater than 0. Sorry about that, that wouldn't make any sense. Your base must be greater than 0, so you cannot have a negative base. Now don't get confused. You can have a negative 2 right here, that's fine. You could even have this, negative 5x plus 6. No, Mr. Error, you can't because your 5 is negative. No, the 5 is a positive 5 with an imaginary negative 1 right there, okay? The only way your base is negative is if you had it written like that. Now your base is negative, okay? So make sure you understand that. But anyways, moving on. Your base must be greater than 0 or positive, however you want to say that, and it cannot equal 1. Your base cannot be 1. Okay, so please understand that. Okay, so this is an example of an exponential function. Now what we're going to do today is we're going to graph them. We are going to graph them, and you're going to find them very easy. They are not difficult, okay? All right, here we go. Here are 4 steps for graphing exponential functions. Step 1, find the horizontal asymptote. And you're like, great, more horizontal asymptotes. Yeah, you're right, but first of all, every exponential function has them. And the horizontal asymptote is so easy to find. It's whatever the constant term is. So in this last problem right here that we were looking at, which one of these is your constant term? -3. So on your graph, where would your horizontal asymptote be? Well, it'd be right here at -3. They're really easy to find, okay? All right, step 2, set the exponent equal to 0 and solve. Why do we do that? Well, this number will be the middle on your table of values. Step 3, make a T of V, that's table of values. Make a table of values with 5 ordered pairs. Remember, use your value from step 2 right here for the middle of your table of values. And then lastly, step number 4, sketch the graph. Sketch the graph. Okay, well, let's go ahead and get started. Let's practice 3 of these problems, and then we'll be done for the whole day. Okay, so that'll be it for your video, and then we can start working on your homework. Okay, problem number 1. F of x equals 2 to the x minus 2 power. Okay, step 1 says find the horizontal asymptote. And it says the horizontal asymptote will always be your constant term. Well, this is not your constant term here. That's your base. X minus 2 is your exponent. So there is no constant term. So you could really put what? Plus 0. Or you could put minus 0. Either way, your constant term is 0. So our horizontal asymptote is going to go right here at 0. So there we go. That was easy enough. Not too difficult. Now step 2 says take the exponent and set it equal to 0 and solve. Okay, bring the 2 over, make it positive, and there we go. And then what step 2 said is this number right here that you get out goes right in the middle of your table of values. Now step 3 says make a table of value with 5 ordered pairs. Take your number from step 2 and put that in the middle. So my 2 is right here, so I'll put a 2 right here. And then we'll just kind of go up. I guess I'll put a, let's see, a 3 and then a 4. And then go down, we'll put a 1 and a 0. Now we can do these pretty quickly in our head. You can also use your graphing calculator if you want to, or a regular calculator. Caleb is totally fine. But if you put a 4 in for x, 4 minus 2 is 2, 2 squared is 4. Put a 3 in for x, 3 minus 2 is 1, 2 to the 1 power is 2. Put a 2 in for x. Now be careful here, 2 minus 2 is 0, and some students think that anything to the 0 power is 0, and that's not true. Anything to the 0 power is 1, so 2 to the 0 power is 1. Now, let's put a 1 in for x. 1 minus 2 is -1, so we have 2 to the -1 power. Now, if you're kind of weak with your negative exponents, really that means to put it over 1, bring the 2 down to the bottom, the 1 becomes positive. But you can use a calculator if you want. If you type in 2 to the -1 power, you're going to get 0.5. And now put 0 in for x. 0 minus 2 is -2, so you have 2 to the -2 power. If you type that into your calculator, you will get 0.25. Okay, so I'm going to quickly graph. Step 4 says to sketch your graph. So I know I have 1, 2, 3, 4, 1, 2, 3, 4. So there's 4, 4, and then over 3 and up 2, and then over 2 and up 1, then over 1 and up a half, then over 0 and up a quarter. And I think you can kind of see the picture of the graph. And usually, I'm not bragging, usually I'm pretty good at starting off the lesson when it's graphing, showing you what the graph will look like, and I didn't, and I apologize. They're always going to be curved like this. They will all look the same. Some will curve quicker, some will be wider, some will be narrower, but they're all going to be curved like this, okay? And so that's basically it. Not too bad. Let's take a look at our next example. Okay, here we go. This is an exponential function. You know that because you have a base of 2. Your base is not -2. Let me say that again. Your base is 2. The only way your base would be a -2 is if it was written like this. If you had plus and then -2 in parentheses, then -x. But that's not what you have. What you have up here is really this. You really have 5 negative, then put an imaginary 1, and then 2 to the -x power. That's another way to rewrite this. But your base is 2, and look, we have a constant term all by itself. The constant term is 5. Okay? Now you say, well, it's not written at the end. Okay, no problem. Write it at the end. No problem. There we go. Plus 5. It doesn't really matter. Your constant term is 5. And so we know we have a horizontal asymptote at 5. I might scoot this down to give you some room. There we go. All right, so 1, 2, 3, 4, 5. So here's your horizontal asymptote, and it's right at positive 5. There we go. Now step 2 says take the exponent and set it equal to 0 and solve. Well, my exponent is negative x. So take negative x, set it equal to 0. Divide both sides by negative 1, and x equals 0. So now, according to step 2, you know what your middle value is going to be on your table of values. So now moving on to step 3, write a table of values that holds 5 ordered pairs. And right in the middle I put a 0. Going up we'll put a 1 and a 2. Going down we'll put a negative 1 and a negative 2. Now let's see what happens here. Let's be really careful with our numbers, okay? We have 5 minus 2 to the negative 2, because where the x is right here, I put a 2. So what I really have is 5 minus, now if you want to with the calculator you can type in 2 to the negative 2, and if you do you will get 0.25. So 5 minus 1/4 would be 4 and 3/4. Okay, now let's put a 1 in for x. 5 minus 2, then a negative, then a 1, because here's x, and I put a 1. Now again, by the way, Matthew, if you've typed this entire thing into your graphing calculator, let me go ahead and just pause for a second, Caleb, and show Matthew something. Matthew, if you wouldn't have typed this whole thing into your graphing calculator, that's fine. It would look like this. You would hit y equals, and then hit 5, then minus, then 2, then arrow, then parentheses, then negative x, then close your parentheses. And I'm doing that right now as I'm talking to you. 5 minus 2, arrow, and then parentheses, negative x. And you'll see that you're getting out the same values that I'm getting out right now. But let's continue on. So you're welcome to use a graphing calculator if you want to. That's fine. Now back to this problem here where I substituted negative 1 in. We would now have 5 minus, and then take 2 to the negative 1, and trust me, that's going to give you a 0.5. So 5 minus a half is going to be 4 and a half. Now we're going to put a 0 in for x. Well, think about it. That would be 5 minus 2 to the 0 power, or negative 0 power, same thing. And anything to 0 power is 1, so you really have 5 minus 1, and so you'll get a 4. And then if you put a negative 1 in, there's already a negative sign there, so you really have 5 minus 2, negative, then negative 1. So it's really a positive 1, and 2 to the positive 1 is 2, and 5 minus 2 is 3. Then put a negative 2 in, but there's already a negative sign there, so negative negative 2 is 2. 2 squared is 4, and 5 minus 4 is 1. So there's your ordered pairs. Let's plot them quickly and see what kind of graph we get. Okay, we're going to go over 2 and up 4 and 3/4, and then over 1 and up 4 and a half, 0 and then 4, negative 1 would be 3, and negative 2 would be 1. So you see the really nice curve that's forming there. And of course, I mean, on your drawing, if you touch the asymptote, I'm not going to take points off, but technically it's getting closer and closer to the horizontal asymptote, but it's not going to cross it. Okay? Now we have one more to do, and this one's going to be a little weird. You might not have known this, but E is a number on your calculator, okay? So let's go ahead and take a look at this problem. First of all, notice another way to rewrite this problem would be like this. Please look. You have a negative 1 and then E and then negative 2x. Because students, I'm going to keep stressing this over and over to you. This negative sign is not part of your base. The only way this negative sign is part of your base E is if there is parentheses around the negative E. And notice in the original problem, there was not any parentheses around the negative E. Okay? So, this is not this negative sign is not part of your base. You could rewrite it like this. It's like having a negative 1 times the base and its exponent. Now, you're saying, Mr. Earhart, E is not a number. Well, I would like to differ with you on that. And Caleb and Matthew, if you'll find the E button on your calculator, Matthew, yours will be on the left column, third from the bottom. So go all the way to the left, count up 3 from the bottom, and you'll see your LN button. And Caleb, you might want to look for your LN button too, and then right above it you'll see an e to the x. So if you guys would go ahead and type in, forget this problem here for a second. Okay, we're just going to do something else for a second here. I want to show you that e is an actual number. If you would hit your e button, this should pop up on your calculators. It should be e arrow and then a parentheses. Go ahead and put a 1. In other words, what that's saying is you're taking e to the 1 power. When you do that, you should get this right here. You should get 2.7182818828, and that's the value of e. E is 2.71828182. I'm not going to get into where they get that from. There is a way they get that number. Instead of getting into that, I'm going to simply say this: you should be able to come up with e values. For example, real quick, let's practice. I would like you to type in 2e to the 5th power. So with your calculator, you would type in e to the 5th power, hit enter, and then times 2. And if you did that correctly, you should get this right here. You should get, and I messed up, so hold on 1 second, please. You should get 296.8263182. If you're not, I really need you to pause and get some help with that, okay? Either ask questions or experiment until you figure it out. Let's do one more. Let's say we had 3e to the negative 10, okay? Well, you want to type in your e to the negative 10 and hit enter, and then multiply it by 3, and you should get, I think it's scientific notation, I think it's 0.0013619978893, or your calculator might say 1.36199 e to the negative 4. Either way, you'll get something like that. But e is a number, and so we're going to look at e here as the base. Now, again, with your calculator, and Matthew, I'm doing this now. If you have a graphing calculator, you can very quickly type this in. I'm going to do that right now. And how I'm going to type it in is I'm simply going to hit negative, not minus, but negative, then hit your E button, and this should pop up. And then in parentheses, you type in negative 2x, and then plus 1. And that should do it, okay? So here we go, negative, and then my E button, and then negative 2x. Close the parentheses. And then plus 1. All right, so there we go. And I've got that all typed in. Now, step 1 says find the horizontal asymptote. Well, I do see a constant term. It's right here, plus 1. And so I know I have a horizontal asymptote at positive 1. Easy enough. Step 2, take the exponent and set it equal to 0. Well, my exponent is negative 2x. Set it equal to 0. Divide both sides by negative 2. And x equals 0. So for my table of values, I'm going to put 0 right in the middle. There we go. And so we have 1, 2, negative 1, negative 2. Now, using your calculators, on my calculator here, I have out that 2 is giving me a 0.98, and 1 is going to give me out 0.86. And 0 is going to give me out 0. Negative 1 will give me out negative 6.4. I'm rounding that. And then negative 2 is going to give me out a negative 53.6. I'm just going to put negative 54. So let's see what happens here. Here we go. I'm going to go over 2 and then up almost to 1. 1, I'm going to go to 0.8. 0, I'm going to go to 0. Negative 1 is going to go way down here to 6.4. And then, of course, negative 2 is going to be way down here. So it's shooting down very quickly. And, of course, the curve will be getting closer and closer to the horizontal asymptote up here. And by the way, you might be asking, does this top part right here ever just level out? No, it does not. It's like taking a half and dividing it in half, and then dividing it in half, then dividing it in half, then dividing it in half. It'll keep getting smaller and smaller, but it never will hit a certain number. And same thing with this. Does this part here ever level out? No. It's slowly, no matter how low you go, it's slowly still moving to the left also. Sometimes you can't see that just with the naked eye, but it is true. It is not going to level out. Okay? So that's it. That's how you graph exponential functions. Not too difficult. Just master. The main thing is being able to, excuse me for a second, getting a drink there. Thank you. The main thing is first of all be able to recognize the constant term so that you know where the horizontal asymptote is. And the second thing is be able to type these into your calculators really well, or be able to evaluate these really well so your table of values is correct. And the rest of it's pretty simple. Okay? All right, here's your homework for tonight. I've given you 3 problems here in which you're proving inverses by composition. And then over here I've given you a couple E problems that you're not graphing. You just type into your calculator something like e to the 7th power or something like that. And then I've given you some graphing here. 13 through 41 would be, let's see, 23, 33, 40, 38, 13, this might be wrong. Hold on one second. 13, 23, 33, 28. So 14, 7, 8. 8 graphing problems. Okay, that's not bad. That's 8, 9, 10, about 13 problems altogether. 8 of them will be graphing. Okay, so that's it. Call or email if you have any questions. I hope this has made sense to you guys. And again, contact me if you have any questions. Have a good day today.